Okay, I did speak with one robotic expert, and he. Hello.
Oh, really?
Is it okay?
Yeah, of course. We'll have it moving here in a little bit as well.
Okay. Hello. Hey guys, I think we're going to check out some robotic stuff today. We'll learn things on how this robot works.
I got it.
I'm also
No.
curious. I'm going to talk to some of the experts to find out what's going on. Good to meet you, first of all.
Hey, nice to meet you. So it's a robot. It's a minimal viable humanoid robot. We are Diligent Robotics. This is our robot Moxie. It does point-to-point deliveries inside hospitals. So we deliver medication, lab supplies, lab samples, small-scale equipment from one spot to another inside a hospital. Right now, basically, we are trying to help the nurses, give time back to the nurses. Nurses spend like around 40% of their time doing deliveries inside hospitals. They do 4.9 miles a shift. And what we're trying to do is help alleviate that burden, to let the robot do all the delivery tasks and let nurses focus on what's actually important, which is the patient care.
What type of technical skills is required for someone to build something like this?
I mean, there are a lot of, like, robotics is an amalgamation of a lot of technical skills, right? So if there is hardware design, there is manufacturing, there is embedded software, there is low-level software, there is writing drivers, there is higher level software in terms of behavior tree systems, behavior systems. There is AI modeling, so there is AI model training, AI model deployment, quantization for edge deployment. So yeah, it's like robotics is an amalgamation of a lot of different engineering skills, and people who have expertise in any of those skills can be roboticists.
Makes sense. So I have a follow-up question on that. You mentioned about AI. There's a lot of AI engineers out there who wants to get into robotics,
Yeah.
right? So how much of it is reusable? What AI runs in this one, right? What type of AI runs in this one?
Yeah, I think a lot of stuff that general AI engineers learn is reusable, right? In terms of how large models work, what it needs, the amount of data requires to train them, the data cleaning pipeline, the job orchestration pipelines, the actual training, and then model distillation. All of those skills apply. However, there are certain things that are unique to robotics, right? For example, the requirement for understanding 3D space and how things operate in 3D space, the requirement to understand different frames of different field of views and different frames of reference, right? These are things that are unique to robotics. These are skills that can be picked up, but they are unique to robotics, right? So understanding of arm trajectories, right? Which is not something a usual AI class would teach you if you're just working on computer vision.
So arm trajectory, that's what I'm actually curious.
Yes.
So you have single arm,
Yes.
not both, two arms. Is there a reason why you just focused on one is single arm for this use case or something?
Yeah, so the reason we are focused on just a single arm is the tasks we are doing right now require just the one arm, right?
Okay.
And we don't want to overcomplicate the robot. So for example, right now, Moxie, while doing deliveries, it is required to press buttons, do badge scans, to open doors, take elevators.
Okay.
So for that, this single arm is sufficient, right? We are able to do that.
Can you show me once how it does?
Yes, absolutely. Basically, we are trying to simulate a hospital environment here. Of course, like, we are in a tiny booth, so we are trying to make a simulation. But what I'll do is I'll scan my badge right here. This gives me access to be able to unload the robot drawers. So if I were inside a hospital, I'd unload these drawers. If I'm a nurse, I can load the drawers now, right? I can pop the drawers back in. And then in a second, the robot would be on its way. Now, what we have over here is we have put up a badge scanner here, right? And a lot of areas inside a hospital are restricted by badges. Okay. So what we are trying to simulate is that environment. So the robot will go, it will wave its arm in front of the badge to trigger the badge scanner, and then it will make its way through the rest of the corridor.
Interesting.
So yeah, you'll see it go in a second.
Dumb question when it's working. So I see there is a camera here.
Yeah.
Is it two cameras or what's going on here?
Yeah, so this is an RGBD sensor.
Okay.
This is RealSense 435D. So it also has an IR sensor and an IR emitter on it. So that's why you're seeing two. So, and the IR sensor is used for depth measurements.
Got it. And this one, what is the purpose of this one?
Yeah, so this is just a fisheye camera.
Okay.
This is a fisheye camera. And this is a planar LiDAR right back.
But making sure the surrounding is kind of clear. And
Yeah, absolutely. So there you see the robot moves its arm, does the badge scan. Now we are assuming that it has access to whatever restricted area it was trying to go into, and the robot's going to make progress. Right, so it has reached its destination and it's asking me to scan my badge again, and then once I scan my badge again, I can select which drawers. So I select just the large drawer, right? So yeah, that's a small sample of the end-to-end operation.
So the hand gestures are usually for a different type of activity.
Yeah, there are some hand gestures, but usually the hand is used for badge scanning, pressing a button. So you'll see while it's coming back, it's going to press that button.
Okay,
And usually those are ADA buttons inside hospitals
Makes sense.
that are used to open doors.
Okay.
Right? So it's going to press that button now. So yeah, it looks at the button, it's going to localize it.
I wish you could shake my hands.
That's everything.
And all this, how does that work to make sure it navigates to the right place?
Yeah, basically these are all perception sensors.
Okay.
And their job is to help robot semantically understand the environment around it, right? So there is this thing, so we have a lot of cameras, we have some LiDARs, and we have a whole suite of perception sensors.
Okay.
The job of these sensors, the job of the algorithms, whether they be AI algorithms or classical perception algorithms, is to combine this sensor data to build a 3D understanding of the scene around it, right?
Okay.
So the reason these sensors are used is to help the robot understand where it is in the environment, which is called localization, right? Where am I in the environment, in the giant map? The other is to make sure that this is a wall, I can't collide into it. This is a dynamic agent, this is the direction in which the dynamic agent is going, and I should plan my way around them.
Do you have to train it on a specific location, or does it know automatically? Let's say I take it, I put it in a brand new location. Can it do it, or do you have to train the location?
Depends. So the perception, we don't have to train it specifically, right? So the perception of the robot being around dynamic agents and navigating around dynamic agents, we already have data sets for it. We have different algorithms of it. Some of them are way more data driven than others. So we don't have to, those largely transfer. We also have a huge data set where the robots has deployed. So we don't have to mess around with them too much. However, there are certain cases where there are different kind of elevator buttons, right? Or different kind of badge scanners, which the robot has never seen before. So in those cases, we do have to add those sets to our training set, that data to our training set, and train for those explicitly.
And because you mentioned about training sets, right? This is a topic that I'm definitely curious about.
Yeah.
Because there are two types of training. One is the hand gesture training, and of course the amount of data you have to capture and process and train. Can you give me an example of here's how we can do? That'll be helpful.
Yeah, there are like different kinds of models so that we're working with. So some of them are purely perception models. So some of the things we have deployed on it are models that are able to take a model that is able to take the sensor data, so all the camera data, all the LiDAR data, and build a 3D understanding of the world. So do monocular depth estimation, semantic segmentation, right? That's one kind. Now we're also working on VLA models.
Yeah.
The VLA models are vision language action models. They are more end-to-end models that we are working on right now. And those models they directly go from sensor data to trajectories for the robot arm, right? So they intake sensor data and let's say even a language prompt. So I want to say that you are in front of this elevator panel, press floor button 5.
Yeah.
So the models we are trying to train are the robot just takes in the camera data, the state of the arm, and is the model, the VLA model, is able to take that along with the language prompt, and then spit out an arm trajectory.
Makes sense. Yeah. Makes sense. That's awesome. Really, really appreciate you.
Yes, thank
for the guidance. Assuming this is just more for making it easier. Is there a reason why you have to put a head? Because it does not have any purpose, right?
It does, right? So basically, did you see that when it was trying to press the button,
Yeah.
the head rotated?
So you have to move the whole thing.
Yes, correct.
Okay.
So instead of having to move the whole thing, you can just rotate the head more naturally like
Okay.
we do. It can perceive the button, hit it, and then keep going.
Okay.
So no.